Welcome to a new module, Module 9. We are going to be learning about rational functions in this module. So when you hear rational, I want you to think ratio. Something like A to B. Another way to write this ratio is A over B or A divided by B. So when we talk about rational expressions, we're talking about polynomials in a fraction form. Something else that is coming up again, you've seen once before, are complex fractions. So we're going to start our rational functions chapter with simplifying, multiplying, and dividing rational expressions. So before we get into these polynomials, let me give you a simple example like 35 over 40. You might immediately think that both of these can be divided by 5, and so my answer would be 7/8. But let's think about this in terms of writing out multiples. 5 times 7 makes 35, and 5 times 8 makes 40. What I'm essentially doing is I'm canceling out my like terms over the fraction line to get my answer of 7/8. In a polynomial, we would do the same thing. First, I'm going to write it out into multiples. In other words, I'm going to factor x squared plus 7x plus 10. You can see those factors. Do the same for the denominator and look across the fraction line to see if we can cancel out any like terms. My simplification of this polynomial would be x plus 5 over x minus 3. So in terms of this, I have one more question. Are all rational expressions defined for the values of x? Think about if there's any value that this fraction could not include. X cannot be which number? Please answer, are all rational expressions defined for values of x? Yes or no, and why, before you move on. Hopefully you got your answer, and I can confirm undefined is going to happen. So hopefully your answer was yes, and in a minute, if you didn't get it, here's why. Simplify this as practice. X squared minus 2x minus 24. Which numbers multiply to make 24 and add to make 2? 6 and 4, making 6 negative and 4 positive, will keep these signs correct as well. In the denominator, I notice before I factor, each term is divisible by 2x. So I write my denominator first, then I'll factor. Looking for a number that multiplies to be negative 4, adds to be 3. And in doing this, I do have some like terms to cancel out. I write what's remaining, and then my next step. The expression is undefined when 2x and x minus 1 are equal to 0. Why? Because a denominator cannot equal 0. We can't divide by 0. In other words, we're going to put each multiple equal to 0 and find what x would make this denominator 0. In this case, because we have two factors, we have two answers. X cannot equal 0 or 1. In addition to factoring, there is some rewriting skills that you might need to use to simplify a rational expression. In my first term on the numerator, I can divide out an x. So I'm left with 6x minus 5y. Then I look to see, is there anything I can cancel? And I don't have anything, but I see that these two are very similar. They both have a term that's 6x, and they both have a term that's 5y. The signs are just different. So this is an example that we're going to use negative 1 to rewrite and cancel. Working with my numerator, I'm going to factor out negative 1 and rewrite. Notice how I switched orders as well. So rewrite this term. Here's the first step. I took out -1, changing the sign of 6x, changing the sign of 5y. Then I just flipped them like this. Let's rewrite that numerator. We have x, but we have to multiply it by -1 now. So I have -x times 5y minus 6x, and then everything else copies. Now I see I have some like terms, and I rewrite my answer. In this problem, we do not need to find what's undefined, and the reason is because we have two variables, x and y. So we're not able to identify a term that would make this undefined. We don't have enough information. So that's your final answer. Now that we can simplify, let's start multiplying and dividing, which is basically mass simplification. There's going to be factoring, as you can see here. There's going to be canceling, and then we're going to have a simplified answer and what it cannot be defined as. Division is almost exactly the same, except we need to remember this rule. When we divide fraction, let's say we wanted to divide 1/2 divided by 3/4, we would actually multiply by the reciprocal. So when we're dividing polynomials, you'll see the same thing. We're going to factor everything, as you can see in this step, but notice that this has been flipped. Simplify, and then write what x cannot equal or where it's undefined. Let's try. Example 3, we're going to do some simple multiplication and division, just one term. In this lesson, I'm going to write out these in the least common multiples, but I won't do this in class. I just want you to see it one time. Essentially what I'm doing is I'm pulling out any common factors across this fraction line. So I just go through, and for as many repeats as I have across the fraction line, I cancel them out, write what's left, and then use exponents. There's my multiplication. Another way to do it is to just go back to the original here, and across the fraction line, cancel out. I see I have x's I can cancel. I have 1y, so this is going to become 2. I know that I can divide a 4 out of here, leaving 2. I take a 4 out of there, I have 3. I just looked over to the right. Did you see that I didn't finish? I didn't reduce my 4 into 2s. What was I doing over there? Okay. Oh, wait. Still do it. Got to get rid of that. One more time. We should have 2y cubed. Okay, back to what I was doing. We have a 9, which is reduced by 2 3s, so those go away. And now I just write what's left. I have an x squared that hasn't been canceled out. I have a 2, and then I have a y squared. So you can just kind of piece together in your head and cross out like that, or you could write it all out and then start canceling. Don't make that mistake. Write that as 2s so you don't forget anything. But hopefully that helps you visualize what we're doing. Let's do letter B, the division. The first thing I'm going to do is rewrite it into multiplication of the reciprocal. Now look to cancel. Now I can rewrite what's left, which should be 2 times d squared over this times this, 9 times c cubed. Everything else was eliminated, so that's going to be my final answer. Here is an application of multiplying and dividing. I have it here so we can refer back to an example when we have a word problem on our practice. Basically, this is looking at area. So we have the area for one planter and the area for a second planter, and they want you to represent in a ratio. Remember that ratio means division. So I'm going to divide these two polynomials, as you can see here. After that, it's the same work. We're going to first we're going to multiply by the reciprocal. Then we're going to factor everything that we can and look to eliminate my common factors, write what's left. We know that in this case, x cannot equal negative 20. But because we are just writing the ratio, that is an optional task. So we don't need it this time. The instructions will help you to remember to write what's undefined when needed. Here's our last challenge division problem. Can you simplify a complex fraction? In other words, we have division divided by more division. Start by writing it out. We have our numerator divided by our denominator. Once you separate them, you have a simple division problem. We actually multiply by the reciprocal. Then we're going to factor. It's the distributive property, but basically we're factoring out any common factors like a 4. Write what's left. Then look to eliminate any common factors across the fraction line. Then write what's left, and that's your simplification. Here's your challenge. Pause here and try. See how you do. When you're ready, resume for the answer. First step, did you write out your division? And can I show you a trick? Notice what I did here. I'm going to lead with my x term. So instead of 3 minus x, I write negative x plus 3. Then I flip to multiply by the reciprocal. Now I need to factor. I also should point out my x plus 2 squared, I did write out into multiples just to make it easier to cancel later. I notice I can factor 3x minus 9 and x squared plus 14x plus 24. I'm also going to show you that keeping your x term positive is important. I'm going to rewrite negative x plus 3 as negative 1 times x minus 3. Now I look across the fraction line to see what I can cancel, noting that as I was talking, I wrote the wrong number here. Now it's right. Across the fraction line, we go. My x plus 2's cancel out. By rewriting, I can now cancel out that x minus 3. And finally, I write what's left. It is in proper form to leave a negative 1 in the denominator, so I'm actually going to apply it up here instead. In other words, I'm multiplying this whole thing by negative 1. So my final answer is negative 3 times x plus 12 over x plus 2. There are some tricky simplifications for us to work on, and practice is what's going to help you progress. Here are the correct steps in the wrong order. Can you put them in order before seeing my answer? Pause here and give it a try. Here are the order of steps. Let's tackle this advanced complex fraction problem. We need to have, I did my steps out of order. We need to rewrite the numerator and denominator so they're a single fraction before we begin. Then we'll rewrite it as a division problem, invert the second fraction, and multiply them together. The challenge is writing as a single fraction. What I'm going to do is find the common denominator by multiplying it together. So 4m is my common denominator. Here I needed an m to get that common denominator, so I multiply the top and the bottom. Here I needed a 4, so I multiply the top and the bottom by 4 and combine to get m squared minus 4 over 4m. Now let's tackle the denominator. Notice I'm going to write 1 as a fraction just to help see the common denominator, which is going to be m. The second fraction already has that m, so I only need to multiply the first fraction, top and bottom, by m, and then I write what's left. We have m plus m, which is going to give me 2m's, plus 4, all over my single m. Now we have a division problem. So we divide or multiply by the reciprocal. Next, let's factor. We have the difference of squares, so I can factor m squared minus 4. And we have a common factor in 2m plus 4. Look across the fraction line to cancel. It's kind of fun, right? Once we get to this point. Now let's write what's left. M minus 2 is left in the numerator, and I have a 4 times 2 to get 8. We cannot cancel. I know you want to, but these do not cancel. That is incorrect. Both terms must have a 2 in order for that to cancel out. But we cannot cancel just these guys. That would be a wrong process. Don't do it. We'll talk about it more in class. With that, I encourage you that you have the power to persevere through this new chapter. I know it's going to be challenging, but we'll get through it together. So turn in these notes to 9.1 and make sure you've taken note of any questions that you'd like to bring up in class. I'll see you then.